In this lesson, we would understand how to determine displacement in two dimensions. There are two different methods to determine displacement in two dimensions. The first method is called the scale diagram method, and the second method is called the cosine and sine law method. In this lesson, we would just discuss the cosine and sine law method to determine the displacement in two dimensions. In order to understand the method of cosine and sine law to calculate the displacement, we first need to understand how to draw displacement vector in two dimensions. Suppose you're walking to your friend's house and you take a shortcut across an open field. Your first displacement is displacement vector 1, which is 140 meters east, 35 degrees south. This can also be read as 35 degrees south of east. Then you turn and cover the displacement of 200 meters north, 40 degrees east. Now, if you're asked to determine the total displacement, which will be represented like this, we would first draw displacement 1 and displacement 2 vector. The two vectors can be drawn on the same grid or they can be drawn on the separate grid. The calculation becomes easier if we draw the two vectors on separate grids. So the first known vector is d1, which is 140 meters in the direction 35 degrees south of east. Because this represents north, this represents south, this represents east, and this represents west, any vector in between east and south will lie in this region. Since this vector is 35 degrees south of east, so the easier process to understand to draw the vector angle is to attach this 35 degrees to the first direction that we see in the vector value. Therefore, in this case, it would be 35-degree angle made with east direction. Similarly, to draw the second vector d2, the direction lies in between north and east, that is between this and this, as the angle made is 40 degrees with the north. So we would draw the vector making an angle 40 degrees. So we would draw the vector making an angle of 40 degrees with north in between north and east. In order to understand the calculations for any vector that does not lie on the x and the y axes and instead lies in between x and y axes, for example, in this case, the d1 vector lies in between the east and the south, where east represents the x-axis and south represents the y-axis. We always split the vector into its components. That is also called component method. It helps us know the value of this vector on the x-axis as well as the value of the vector on its y-axis. To organize the values well, it's always a good idea to make an x and y-axis chart, or we can call it as table. This is vector d1 and the blue color will represent vector d2. We would split each vector into its x and y components. In order to split the vector into x and y components, we have to see where is the angle attached. If the angle is attached to the x component, that is for vector d1, since this angle 35 degrees is attached to the x component, we would say the x component is adjacent to the angle. And as it is expected from the prerequisite knowledge that cos of any angle is adjacent over hypotenuse, we don't have to worry about what is the hypotenuse value. All we have to worry about is adjacent means cos and opposite means sine. So this is the information that we would be using in order to help us understand how to split this vector into its components. Because x is adjacent for d1 vector angle 35 degrees, so in order to determine the x component, we would do cos of the angle multiplied by the value of vector d1. And the value of vector d1 was 140 meters. This would give us the value of the x component of d1. The direction stays the same as we see in the diagram. So this is going to be east. And the value that we get is 114.68 meters. We always put the direction of the value of the x component and y component because we're talking about vectors. Now going to the y component for vector d1, because this vector d1 lies in between east and south, so its y component will lie on the south axis. And since south is opposite for angle 35, so we would be using sine of the angle 35 times the vector value, which is 140 meters. This would give us 80.30 meters in the direction of south. Now let's use the same process to define the components of vector d2. Since this vector d2 lies in between east and north axes, so its x component will lie on the east axis and its y component will lie on the north axis. Now to determine the cos and sine of the angle, we would see what is this angle adjacent to. This angle is adjacent to the y-axis, as the vertical axis is always y-axis and horizontal axis is always x-axis. So in this case, to determine the x component, we would not use cos and we would use sine instead. Therefore, we would get sine 40 degree times the direction vector. The value of this direction vector d2 was 200 meters. So we would do sine 40 times 200, and that would give us 128.56 meters. You can always write down the answer up to 2 decimal places. So rounded for 2 decimal places. The direction on the x-axis is again east. So we would write down east direction here. To get the y component, because the angle is adjacent to y, we would be using cosine of the angle times the vector value, that is 200 meters, and this would give us 153.21 meters in north axis or in direction north. We would do this exact same thing if we were given vectors more than 2 as well. It's just that in the third row we would put the vector d3 and so on. However, in this question we are just given 2 vectors, d1 and d2. So the next step is to determine d net. So the next step is to determine d total. However, we have to remember here that the d total that we write down under the x column is going to give us a d total on the x-axis, and the d total that we write down under y column is going to give us the d total on y-axis. In this case, in the x-axis, we have 2 displacement components which are both in east direction. Since they both are in the same direction, they will be added up. For the sake of convenience, we can always use east as positive value, west as negative value, north is positive, and south is negative. Since both the values of x components are positive, so we would just simply add them up, and this would give us 243.24 meters. Make sure to write down your direction, and it's east in this case because both are in the same direction. When it comes to the d total in the y-axis, we would look at both the directions, and since one is south, it would represent a negative value. The one that is north is going to represent a positive value. And finally, we would get 72.91 meters. Here we have to remember that we can't put south or north because we feel like the direction that goes is always the one that is the bigger value. Since 153.2 is bigger than 80.3, so the direction that we would put here is north. Just keep in mind here that dt that we've got in this case is not yet the final answer. We've got dt for 2 components, that is the x and the y component. If you're supposed to draw, this is how it's going to look like. So this is d total on the x-axis, which we have got as 243.2 meters east, and the other one is d total on the y-axis, and the value that we've got is 72.91 meters. The rule for drawing vector diagrams always states that the first vector's head joins the second vector's tail. As we've drawn, x component is the first vector and the y component is the second vector. So the head of x component will join the tail of the y component, and the resultant vector is the vector that joins the first vector's tail to the second vector's head. This will be our d total final that we are looking to find out. Since we noticed that we have a right angle triangle, and this represents the hypotenuse side of this triangle, and we know the other 2 sides, So we would be using Pythagorean theorem here, and the resultant will be square root of 243.2 square, that is the x component, plus 72.91 square, that's the y component. This would give us the final answer as 253.89 meters. Always remember that when we have to find the final solution, we need to find both the magnitude and the direction of that vector. And in order to determine the direction of vector d total, that is here, we will represent it as angle theta. For this angle theta, we know the opposite value as well as we know the adjacent value. So we would use the trig ratio tan theta is opposite over adjacent, which is 72.91 meters divided by 243.2 meters. And finally, to get angle theta, we will be doing tan inverse of 72.91 over 243.2. This would give us the angle 16.9 degrees. We can always round it to the nearest whole number. Now the process to write down the angle is, we would see where is this theta lying. For this theta rests on the x-axis, which is east in this case. So we would always mention the first direction where the theta is sitting on, then the measure of the angle, which is 17 degrees, and the direction that is opposite to it, because it's going upwards, so it's north. In order to write the final answer, it's also necessary to consider the correct significant digits. The correct significant digits are determined from the number of significant digits given in the question. So let's go back to the values that we were given in the question. We were given one displacement vector as 140 meters, and the other displacement vector as 200 meters. When we count the number of significant digits in the first vector, we see there are two significant digits, whereas in the second vector, we have one significant digit. The final answer should always go in accordance to the lowest number of significant digits. So our final answer should contain one significant digit. Therefore, the final answer in this situation would be the total displacement value is equal to 2 times 10 to the power of 2 meters east 17 degrees north. How did we get this answer is, we always round the value to the correct place of the significant digits that we require. Therefore, here we decide to round it at hundreds place, and we check the number at the right side of 100, which is 5. If the number is 5 and the number that you're rounding is an even number, then the even number will stay as is. In case this was an odd number, then it would be rounded up when there is a 5 beside that number. Hence, our total displacement value is 2.0 times 10 to the power 2 meters east 17 degrees north.